mean of the population mean is this. We are given that the sample size is 45, and we're asked to assume that the standard deviation of the population is 5,900. Okay, so in order to determine this, remember, we know that X bar is approximately normal with the same mean, mandatory, the same mean, and the standard deviation is smaller than the standard deviation for X. So this is mu X and this is sigma X to be exact. So this will be sigma X, which is 5900, divided by the square root of 45. My calculator is waiting, wrapped in plastic, because as I told you, I spilled water on the previous one and I had to toss it actually. So in order to determine this, we go to stats and distributions. We will pick normal CDF, cumulative density function, from negative infinity to 575,000, 2 zeros. So press enter. I have negative infinity. The upper is 57500. The mean is given to us as 60,000. And the standard deviation is given to us as 5,900. Some calculators may not look like this one. It's okay. You still have to write from negative infinity, comma, 57,500, comma, 60,000, comma, 5,900. Okay? So it'll appear like this. And when you press enter, you get that probability. And they want 4 decimal places. So I will write 0.3359 because it's 588. So I'm going to share now. Where's my mouse for that device? Okay. So I will put in, okay, I have to bring my, okay, 0.3359. I read again. Round to 4 decimal places as needed. Probably that the mean salary of the sample is less than. Okay, I'm checking the answer. First, what does it say? The parameters of the sampling is used in the central limit theorem, then use parameters to convert the boundary. There is no need for that. There is no need for that. Did I enter 5,900? I did. 45, did I? Oh, yeah, that's what I did. I wrote it here, but I didn't write it here. Sorry. Sorry. Sigma divided by, I wrote it here. So my apologies. I just rushed. Of course. 5,900 over 4, let's go to 45. I mentioned it 3 times and I did something else. Sorry. So it's 0.0022. That's it. Oh, you couldn't see what I was showing. Sorry about that. I was showing this, which I have it right here. But when I plugged it in the normal PDF, I only wrote 5,900 instead of writing this. That's what I was thinking. I was showing, but you couldn't see. So it's, but their explanation, it's not. 0.0022. Sorry about that. So the point I'm making is never rush. Okay, that was problem 9. So let's look at 14. Oh, so there is a part B. Interpret the results. Choose the correct answer below. So about point, so this is 0.22%. About no, 22% no. The first and the last make no sense. Only of the sample of 45 specialists will have a mean salary less. Only 45%, about 0.22 of the samples of 45 will have a mean salary less than. This is not unusual. This is unusual. 0.22% is even less than 1%. So this is unusual. Only 0.22% of samples of 45 specialists will have a mean salary less than blah, blah, blah. This is an unusual event. Yes, it is. It's less than 1%. So it's the same with the lottery. Very, very low percentage. Unusual. Okay, sorry about that. Problem, we said 14. Let's look at 14. 14, where are you, 14? Okay. The overhead reach distances of adult females are not normally distributed with the are okay. So I'm gonna copy my information. So in problem 14, it says with a mean of, so mu sub x is 205.5, and the standard deviation sigma sub x is 7.8 centimeters. Okay, perfect. Then find the probability that an individual distance is greater than. So I'm going to copy all of them so I don't have to go back till I put the result. Find the probability that an individual distance is, so P, that x is greater than 214.80. Part B, find the probability that the mean, that x bar for n equals 15, randomly selected, is greater than 203.3. Okay, and the last one, why can the normal distribution be used in part B even though the sample size does not exceed 30? Okay, so then we're going to come back to C. So I'm going to stop sharing. Okay, so again, X is normally distributed with 205.5 and sigma 7.8, but X bar is normally distributed with 205.5, and let's see if I forget now to divide by the square root of 15. Hopefully I won't. Once a day is enough. So when I determine this, I will use this information. When I determine this, I will use the mean and the standard deviation. Ready? So again, go back to normal CDF. This time we start at 2.214.8. That's our starting point, and we go to positive infinity. Again, infinity is second EE99. And the mean is 205.5. And the standard deviation is 7.8. It's about X. And I press enter and I get 0.1165. 0.1166. We'll come back to put it in a minute. Now I redo normal distribution, normal CDF. That's not what I meant. Okay, so now lower is 203.3. Upper is still infinity. Mean is still that. However, this is 7.8, but divided by the square root of 15. And close the parenthesis. And now I paste. And now I get 0.8627. Okay, I am going to start sharing. So the probability is for X to be greater than 2.214.8. I got my keyboard again. I got 0.1166. Round to 4 decimal places as needed. Okay. In part B, I got 0.8627. Where am I typing? Who knows? 8627. 0.8627. Yes. Round to 4 decimal places as needed. Yes. Okay. Now in part C, choose the correct answer below. Okay. Let's see what they want. There was, why can the normal distribution be used in part B even though the sample size does not exceed 30? The normal distribution can be used because the finite population correction factor is small. The normal distribution can be used because the probability is less. The normal distribution can be used because the mean is large. The normal distribution can be used because the original population has a normal distribution. Absolutely. We are told The overhead reach distances of adult females are normally distributed with a mean. If the population is normally distributed, the sample distribution of the sample mean, the sampling distribution of the sample mean, which is X bar, will definitely be normal. There is no discussion there. Any questions? Do we have anything else? Can I stop sharing now? Okay, I'll leave it open because we'll come back to the rest. Okay, what am I doing next? Here. This is where I'm now. Does anyone have any questions? Thank you, Sean. They were very good questions. Anyone else having any questions? Anything? Okay. In that case, we will try to, today, if we can, complete 8.2, which should not take long. And we will start chapter 9. Hopefully, we will be able to accomplish section 9.1. And I meant to create a quiz today, but I had a question from a student from a different class, and it took me, I opened a Zoom session for him, etc., etc. So it took me longer. So please get ready for Wednesday, of course. Okay. So here's population. And we already know several parameters, population parameter. We know the mean, we know the standard deviation of the population. We will talk about proportion. We know the coefficient of determination. We know a lot of parameters. Now, we also know that statistic will be, for mu corresponding will be X bar. For sigma corresponding will be lowercase s. All these come from the sample, Because we want to estimate this using this. We want to estimate this using this. Okay. We will be using p hat to estimate p, and so on and so forth. So these are the ones we are going to be focusing on for the rest of the semester. Mean and proportion. Okay. So these are statistics because, or each a statistic because they come from the sample, and we want to estimate them. So they are called statistic. X bar is an estimate of mu, but also they are called a point estimate of mu. This one is the point estimate of the population proportion. So today we're going to look at proportion, both in chapter 8 and 9, hopefully. And then we'll finish chapter 9 going back to the sample mean and population mean. Okay. So keep in mind two new vocabulary if you want. Statistic, but also called point estimates. Okay. The point estimate of a population proportion is called p hat. It comes from the sample and is x divided by sample size. We know n. This is the population, it's the sample proportion. Sample proportion. We know what n is, the sample size, but what does x represent? X is the number of successes. What does that mean? For example, I have an example right here for you. The Harris poll conducted a survey of 1,200 adult Americans. So obviously that's our sample size. There is no discussion there. 1,200. Who vacation during the summer and asked whether the individuals plan to work while on summer vacation. Of those surveyed, that's our X. X is 552. Number of successes indicated that they plan to work while on vacation. The study is about working during vacation. So 552 of those 1,200 said, yeah, I will work while on vacation. Find the sample proportion of individuals surveyed who planned to work while on summer vacation. That's our sample proportion. It's called P hat. And in our example will be 552 over 1,200. That's the sample proportion. And when we divide 552 by 1,200, we get 0.46. So 46% of those surveyed said yes. I will work while on vacation. Also, we can conclude, my camera may cut off. I just need to move this hub from here, and it may cut off my camera for a second. I'm so sorry. It's in the way of me pushing my papers up. Did it cut off? No, it didn't. Okay, thank you. Sorry about that. Okay, so what does P hat represent? Is the point estimate of the population proportion of all people who work over the summer. Okay? Of the population proportion, which is P. So P hat is a point estimate of P. We cannot get P. We cannot survey everyone. It's too costly. We don't have the time. So we selected a random sample, simple random sample. We created the population, the sample proportion, and we said it's likely that about 46% of us will work over the summer while on vacation. Okay, now we want to talk about the distribution of this. Remember what we said? We just looked at a very good example. We said X bar was normal with mu X and sigma X. And then from here we concluded, sorry, not X bar, but X I meant to write. Then from here we concluded that X bar was normal mu X sigma X over the square root of n for any n. We're going to do a proper analysis, similar analysis for the population proportion, for the sample proportion. Okay. So I said to myself, I would like to show you some graphs. And I really like the graphs, and I'm going to share because I don't want to just give you the result. It's fine. The result is good. But I also would like us to look at just 3 graphs quickly